Hi, this presentation is on the domain of polynomial functions and rational functions. So we're going to start with the domain of polynomial functions. The domain of any polynomial function is all real numbers. If we use interval notation, it will be parenthesis negative infinity, positive infinity, close parenthesis. Example 2a, this is a polynomial function, and we know that 2 can be subtracted from any real number. So you got x minus 2, so 2 can be subtracted from any real number. After you subtracted 2 from any number, that number can be multiplied by 3. Any number can be multiplied by 3. And for that reason, this function can actually process any real number. It can take as an input any real number because the domain is a set of values that a function can process and produces a range or an output. So it takes in an input and processes that input and then produces an output. So domain, the function processes the domain and produces a range. Input, function, output. So this function, you can process any number. So therefore, the domain would be all real numbers. So d equals negative infinity, positive infinity. Example B, that's another example of a polynomial. X squared plus x minus 12, that's a polynomial. So for that reason, we know that the domain would be negative infinity, positive infinity. We know that any number can be squared. You can square any real number. You can add any two real numbers. You can subtract 12 from any real number. And for this reason, the domain would include all possible real numbers. The domain of rational functions. So rational functions are different than polynomial functions. So the domain of a rational function is not automatically all real numbers. There are some rational functions uh, whose domain is all real numbers, but that's not the general rule. So let's look at how we determine the domain of a rational function. So because a rational function is a ratio of two polynomials, that means we are dividing by one polynomial. And because we are dividing, we want to make sure that we do not divide by 0. So that means the denominator of any rational function must not equal 0. So we must not substitute some values for x for which the denominator will be 0. So it means the domain of a rational function is every number except the zeros of the denominator. The denominator. And what I mean by the zeros of the denominator, it means the x values that makes the denominator equal 0. That's what it means by the zeros of the denominator. So looking at example 3a, x plus 5 is equal to 0 if x equals negative 5. So because the denominator equals 0 when x equals negative 5, then negative 5 must not be an element of the domain of this function. So we're going to write the interval notation for it. So I'm going to use a number line. on the number line. -5 is somewhere on the number line. What I'm going to do, we're going to have to exclude that -5. -5, we're not going to include it in the domain, but everything else is okay to include. Everything to the left of -5 and everything to the right of -5. So let me just make something like that. So every number, every value to the left of -5 and every value to the right of -5 is included in the domain. So how do I write this domain in interval notation? The line to the left goes to -infinity, on the right goes to +infinity. So the domain D starts at -infinity because we include every single number from -infinity up to -5, and then I'm going to use parentheses to indicate that -5 is not included. Union -5 +infinity. Of course, we use parentheses again before -5 to indicate or to say that -5 is not included. And that's the domain of this function. So work on example B. We got the same idea here. We want to make sure that the denominator does not equal 0 for any value in the domain. So let's find those x values that makes the denominator equals 0. So x squared plus x minus 12 equals 0. If we factor these factors to plus 4 minus, not minus 1, minus 3, or minus 3. Yes, that works. So 4x minus 3, that would be difference of positive x. So the product of x plus 4 and x minus 3 is 0 if x plus 4 is 0 or x minus 3 is 0, or both 0. So x equals -4 or x equals 3. So it means the two x values, or the two numbers that must be excluded from the domain are -4 and 3. So now if I draw a number line, it starts at -infinity, -4, 3, and extends to +infinity. So we said these two values, we must exclude them from the domain, but everything else will be included in the domain. So anything from -infinity to -4, anything between -4 and 3, anything greater than 3. So when I say between -4 and 3, that means not including -4 and 3. From -infinity to -4, that means not including -4. So the domain is starting at -infinity up to -4. We got to use parentheses to say that, okay, we are not including -4. Union -4 comma 3 union 3 comma infinity, and that will be the domain of this rational function. Let's work on example C. Example C, we got a sum of two fractions. We do not need to simplify this expression prior to finding the domain. You can just go ahead and find the domain directly. So 1 over x plus 8, we want to make sure that to exclude the zeros of x plus 8. So x plus 8 is 0 when x equals -8. And then you do the same thing for x minus 10. X minus 10 is 0 when x equals 10. All right, so we're excluding -8 and 10. We can draw a number line. we're excluding -8 and then 10. Want to make sure those two values are not in the domain. So anything else is in the domain. So everything in between or from -infinity to -8, excluding -8, anything from -8 to 10, excluding both -8 and 10, anything from 10 to infinity, of course, excluding 10. So the domain would be d equals -infinity, -8, parenthesis, because we are excluding -8, union -8 to 10, excluding both -8 and 10, union 10 infinity, same thing, we're excluding a 10. Last example, which is example D, f of x equals 7x plus 2 over x squared plus 1. Now, here how we reason with this. X squared plus 1 is actually the sum of two positive values. X squared is positive because it's squared. 1 is positive. A positive plus a positive, that's a positive. So how can I get a 0 by adding two positive numbers? That's not possible. To get a 0, one number has to be positive. Of course, when it comes to addition, one number has to be positive, one number has to be negative, otherwise you cannot get a 0. So this is one way of looking at it. So there are no x values such that the sum of that value squared plus 1 is 0. There is no such an x such that x squared plus 1 equals 0. One way of looking at it. Another way is you try to solve. So when you try to solve, you do x squared plus 1 equals 0, and then, okay, you can move the 1 to the other side. And then again, you got a problem over here because you're saying x squared, which is a positive number, equals a negative number, which is not possible. But if you didn't see this, then you keep on going. So what do you do next? You say, oh, okay, well, x equals plus or minus using the square root property, and you're saying x equals, oh, okay, plus or minus square root of -1. And then we got a problem again, because what is the square root of -1? Well, that's imaginary. This is imaginary. And we're dealing only with real numbers, so we couldn't find any real x value such that the square of that value plus 1 equals 0. So what is the conclusion? What does it mean? So what is the domain of this function in this case? If we could not find any x value such that the square of that value plus 1 equals 0, that means any x value would work. Meaning not to, it works doesn't mean it's going to be 0. No. It means if you plug in any value for x, you square it and you add the 1, you're not going to get a 0. You're not going to get an undefined situation. It would be just it would be a value that we can divide by. We can divide 7x plus 2 by that value. So in this case, we say, okay, well, the domain is all real numbers, because we couldn't find any x such that the square of that x plus 1 is 0. We don't have such an x. So all the x values are fine. They can be processed by this function and get evaluated, and we eventually end up with a value for this function. Thank you for watching.